Let me just show you the bird. As usually we already learned about the bird, very simple bird, and with the bird we can just call in the transformer library. And then when you use the transformer library, we can call the pipeline. The pipeline means we want to use the flow that has been provided. In this case, the transformer was provided by the Hugging Face. And in this pipeline, there are many kind of pipeline. So for example, we want to use text classification. So that text classification, when we learn in the slide, it is to classify into some class. Maybe if it is sentiment, then we have positive and negative. If it is about other things like what you did in the assignment 1, it is clickbait or non-clickbait, and so on. And we are going to use the model. This is the model that you can use for free for base and case. And now I'm going to look at this keyword. So the word BERT is a powerful language model for NLP tasks. So using the model in this text classification pipeline, I want to know what will be the best label for this one. Okay, in this case, the text classification result, it shows the label 1. So label 1, with the score as much as this one. Maybe this is not that obvious because we do not know what is label 1 and what is label 0. So we will take a look more with other examples. Okay, so we can also use the other kind of pipeline, for example, sentiment analysis. So in the sentiment analysis, as you know, we can have like positive and negative. And in this sentiment, we use the BERT. In this case, the model is BERT based on case. And then we have the word I love using transformer library. It's amazing. If we look at this one, it looks like a positive. So if we run this one and we get the label, so the score can represent, if we look at this one, it is more about the positive. So the label 0 is maybe the positive sentiment. Okay, it takes some time. And we can also do with another pipeline, for example, question and answering. So in the question and answering, we can check this question and this context. So we want to know if we have this question and if we have this context, whether they are matching or not. So if I have the question, what is BERT? And then the context, BERT stands for bidirectional encoder representation from transformers. It is a model designed for NLP tasks. So we can try to check whether this answer can represent the question or not. Okay, so this is label 1. So the label 1 has not been indicated, but we can get the label and then we have the score. And in this case, the answering result the score is start from 71 and until 109. So this indicate the token ID. So we need to print the token ID, and the answer, the possible answer from this, it is a model designed for NLP test. So this is the best answer according to the context given on this one. We can also do with the NER, name entity recognition. So we can use the bird, and there's also another strategy. So it depends on your pipeline. So for example, I'm going to check the NER, so we need to define also the aggregation strategy. In this case, we just use the simple strategy to aggregate. For example, like the word new and York, it is two different words. So how can we know that those two represent location? So we need to have a strategy to aggregate multiple words. So the aggregation strategy is simple. In this case, John lives in New York and works for Google. Then if you run, here we have the entity group. So this is the label. Yeah, in this case, it is only the label about the sentence, not the label about each of the word, not about John, not about live. So you need to do something more to indicate John live in New York. So you need to do more things. In this case, the label is only for one word, John lives in New York and works for. And then the other is about the word Google. You can also do something more with the text generation. And this is related to the GPT-2. So let's figure out more later after we learn about the GPT. I give you this pipeline. So the pipelines in Hugging Face, actually the transformer, they use the Hugging Face. And the pipeline contains of many parameters. For example, this one. So you can use audio classification, you can use automatic speech recognition, you can use tip estimation, and so on. Okay. So you can just use this for your application, for example, and then you can check the library, and you can also get the score. So you can get the score, and the score can be compared with some other methods. If you want to do, for example, text classification, if you do with other kind of tasks, of course, they will have their own score. For example, if it is image classification, then you can go to this image classification pipeline, and they will have another score. So you can check on this pipeline. Okay, now let's go back to the slide, and I would like to explain about GPT. What is GPT? The word GPT, it means the generative pre-trained transformer. So we learned about the transformer, and we want to train the transformer, and we use the pre-trained transformer to do some tasks. So in the bird, it can be used to analyze the text. So the text analytics is good using bird. But when you want to generate, what if we want to generate a new output sequence? If you want to generate a text, BERT is not useful. BERT cannot be used to generate an output. So we need to use the GPT. So GPT, so starting from the GPT-1 and GPT-2, later on, we will learn basic GPT-1 and GPT-2. It uses only the transformer decoders. If you look at the BERT, what is BERT? It is bidirectional encoder. But use only encoders. But GPT use only decoder. And in the GPT, there is no encoder. It is to generate new sequences from scratch or from a starting sequence. So if you look at the GPT, it is a collection of decoder, decoder, decoder. If you look at the BERT, it is a collection of encoder, encoder, encoder. So in the GPT, it is a transformer, but there is no attention. So if you learn from the attention, okay, in the deep learning section, in the transformer section, we learn about attention. So there is no attention since there is no transformer encoder to attend. Because there is no encoder, then we cannot use the attention. And for this GPT, there is only self-attention. So each of the keyword will be based on the self-attention. As it processes each word or token, it must, okay, again, the function is to look at the mask. Masking means something that we want to do on the missing value, something that we want to do on the hidden value. And it must the future words and condition on and attends to the previous words. So if you look at this figure, these figures mention that the self-attention, we want to look at every of the input and then we will create one value. So we will create one value and then it will be feed forward to the GPT. But in the mass self-attention, we will put some of the text or the input, and then we will do this one as the mass, as the self-attention, and we keep this one as the mass. And we want to predict what is the possible word of this one, what is the possible word of this one, and what is the possible word for this one. But in the GPT, actually, it does not use words as input, but it uses byte pair encoding, or we call it subwords. And after we have the byte pair encodings, it also includes positional embedding. So we learned the positional embedding and the transform. So after we have this BPE or the byte pair embedding, encoding and the positional embedding, so we can fine tune it to our own data set. So we will learn more about fine tune next week. So the byte pair encoding or BPE, it was developed many years ago by this guy. So if you want to look at the details, you can look at this one. And it has been updated in 2015. in the neural machine translation of rare words with sub-word units. So this paper, they use the idea of the byte pair encoding. The idea of byte pair encoding is looking at the individual symbol or characters and repeated merge the most frequent pairs, or we can look at the methods such as agglomerative clustering. And then stop after n merge. N merge means if you specify n with particular numbers, then it will stop with that number. So GPT use n 40k. 40k means there are 40,000 n. So it means it is 40,000 characters. Then it can predict 40,000 characters ahead or in the future. This is a simple explanation how we can understand from the matrix. If you still remember, in the transformer, we have Q, we have key, and then we have value, V. Now, let's suppose we just look at the Q and the K. So the query, we have the word or the sentence, robot must obey orders. After we have this query, let's suppose we have a value. Okay, so maybe 0 0.1, 0 0.2, maybe 0 0.12, 0 0.15, and so on. And this key will have also value in terms of matrix. So now I don't give the value, but let's suppose after we do the multiplication between Q and K, we got scores. And this scores is before the softmax. And after we have this scores before the softmax, for efficiency, we can still calculate the all query calculation with the matrix multiplication. Then must mean we want to hide some of the possible place before soft maxing. So I know that this scores represent the word such as this one: robot must obey order, robot must obey order, robot must obey order, robot must obey order. Then we want to masking. We want to mask the scores. What does it mean by this mask? So I want to know if I have the word robot, then I must the next word, the next word, the next word. So I must the future. It means after robot, we hide the value. And then the second one, let's assume I have the word robot must. And then the next value also will be hidden, or we want to mask it. So this is the second row. The third row, robot must obey. And then we must the last row. And then the last row, so now for row number 4 means the robot must obey orders. So by giving this infinite value or high value, we call this is masking. We assume that we are going to predict this next one. And after we mask the source, after we mask the scores like this, we do the softmax, and softmax will be done along the rows. So using the softmax function, we have 1 for the first row and 0 for the remaining. For the second row, we have 0.48, 0.52, and 0 for the remaining. This one, we have 0.31, 0.35, 0.34, and 0 for the remaining, and this is the last row. So what does it mean? After we have this score, when the model processes the first example in the data set, so the first example is the row number 1, which contains only one word robot. So it is 100% of its attention will be on that word. So the attention will be only based on the robot. When the model processes the second example, this one, there are 2, robot and mouse. Then when it processes the word mouse, 48% of its attention will be on the robot, and then 52% will be on the word mouse, and so on. So what is the interpretation of the row number 3? The row number 3 means the word obey. The word obey is the row number 3, and we can say that the attention to the word robot is 0.31. This is the attention to the word robot. The attention to the word mouse, it is 0.35. And the word obey, attention to the obey itself is 0.34. What about the last? The last one is the word orders. So we can also interpret the same thing. The word orders, attention to the robot, the value is 0.35. The word order and the attention for the word must, the value is 0.26, and so on. So this is an example. Of course, when you have the word, the scores will be very long, okay? Not only for multiply by 4. And you can look at this kind of scores. The total will be 1. Because the total is 1, then we can know that the higher value means the highest attention. So in GPT, actually, there are several kind of version, and the version depends on the size. So there are GPT-2 small, GPT-2 medium, GPT-2 large, GPT-2 extra large. What is the difference? The difference is the number of decoder. If it is small, then there are only 12 decoder. If it is medium, then there are 24 decoder. If it is large, there are 36 decoder. If it is extra large, there are 48 decoder. So the larger the decoder, of course, it will be more meaningful, or we can find the semantic of the word. And also the dimensionality is high. In the GPT-1, as we already know, the GPT is a model that we use only the decoders. So the transformer decoders only. And the objective is usually about the next word prediction, because I want to generate a new sentence, or I want to generate a sequence of sentence. Then we want to check what is the best possible next word. And usually we just apply the cross entropy loss. The cross entropy loss usually we use for the multi-class classification. Multi-class classification. Okay, I hope that you already learned this one. The cross entropy loss, the binary cross entropy loss. And for the GPT, they use the book corpus. There are 7,000 books from a variety of genres such as adventure, fantasy, and romance. If you want to know more the details, so you can refer to this paper, Improving Language Understanding by Generative Pre-trained. This is the result. As you know, from the previous experiment, the experiment also used the task like MNLI. M. What is M? It is to refer match whether the text match or not. MM. It is mismatch whether the text mismatch or not. And then SNLI. So we know the NLI means the natural language inference. S is the Stanford. So it is the corpus from Stanford, and so on. Okay, so I already explained all this one. Some of them may not provide this task because of the limitation. For example, this is the eSIM and Elmo. This is using the cafe. This is using the stochastic answer network. So some of the metrics are not available, and it is, of course, it is possible. So they also do with other kind of metrics, and they call it, this is the fine-tuned transformer LM. Yeah, and they also try to compare with the bi-LSTM. This is the bi-directional. So we know that bi-LSTM is having a similar structure with BERT, but they are using the LSTM instead of encoder. And this is based on the Elmo and the attention that we look at the previous sample, and using the glue. Glue is the benchmark that I showed previously. It shows the result as much as 64.8. And you can see that the task can be done in the classification. With this, we can classify, let's say, the clickbait or non-clickbait, spam or not spam, and other things, or semantic similarity. So we want to find whether text, the sentence number 1 and sentence number 2 is correlated or not, or the fragment of the sentence are correlated or not, or this query question pairs, whether a question can be answered correctly or not. And among those metrics, so this achieve the highest, but in some cases, like the multitask by LSTM Elmo with attention, yeah, it is still superior. This is GPT-1, but now we have the GPT-4. Of course, the performance is higher than this one. Okay, BERT is a transformer encoder, and as you know, with this encoder, BERT is trained on a lot of text data. So they use the book corpus with the 800 million words and the English Wikipedia 2.5 billion words. The bird-based model, it has 12 transformer block and 12 attention head with 110 million parameters. Meanwhile, the bird large, it has 24 transformer blocks and 16 attention head and 340 m parameters. So it is not easy to do the modeling because it is black box. GPT-2, on the other hand, it is trained on 40 gigabytes of text data, or it is about 8 million web pages with 1.5 billion parameters. GPT-3 is even bigger version with 175 billion parameters. But unfortunately, it is not open source. So when you want to use GPT-2, yeah, it is still okay, it is still free. But from GPT-3, GPT-4, it is not free. So you need to pay some money if you want to use those pretrained model. So there are some concerns. There are several issues to be aware of. It is very costly to train this large model. As you can see, the parameters is million, billion. So the companies who develop this model easily spend an entire month training of one model. You can see, one time training is 1 month. It means 30 days. So if you run with your data now, maybe is only taking 10 minutes or 5 minutes, it is still reasonable. But when you do with very big data, yeah, you can spend month or maybe sometimes more than 1 month. And the electricity is huge. Bird alone is estimated to cost over 1 million US dollar until they got the final model. So this is the approximate value. With 110 million parameter model, they spend around this cost. With this parameter model, they spend about this. With 1.5 billion parameter models, they spend about this money. So you can imagine, yeah, if you don't have good resources, you cannot do this pre-trained model. So in our class, I think, yeah, you don't need to build a model. You don't need to build a pre-trained model, just reuse it. Okay. So this is the data comparison on the how they perform on the large model. So the data size, like this is Wall Street Journal, this is the Wikipedia, this open web text, and then there's also another website, C4. And this is the number of words, billion words. And this is the billion parameters. And this is the training volume. So how many tokens that has been used for the training. And you can see, yeah, Roberta XLNet, it is the highest token among the other pre-trained model. This is the computer that we use, the NVIDIA V100 TGX 2 nodes. Okay. And yeah, this is to indicate that the number of parameters. When they use the nodes, only one, yeah, they can only apply with 1 trillion parameters. When the node is high, 128, so they can apply with higher number of parameters. And the other concern is this very large language model have been shown to be biased. What is bias? It is different between male and female gender. So if it is male, maybe it's more, yeah, better word. For female, maybe it's not better word, and so on. Sometimes it is bias. Race. So some articles mention that the language model still cannot distinguish the race, for example, white and black people. So there are still some issue with that one. Sex, yeah, this is about male, female, masculine, feminine, because some of the words, like in European countries, if you use friends, so they have some feminine words. If you use like Helen, Taigu, so this also has some feminine words. So they still cannot do well on those words. And converting from one language to another often converts gender neutral pronouns to sexist stereotypes. So the translation, this is still issue. Maybe if it is English to Korean, I think it is still neutral. But the translation from English to country with the sexist stereotype, like I mentioned to you, French or some other language which represent female and male different words, so it is still a problem. And using this powerful language model comes with risk of producing such text and or evaluating predicting tasks based on this bias assumption. Maybe the accuracy is high, but it is biased. So we still do not know about that one. And this is the risk. So that's why nowadays in the NLP, they are doing more about the responsible AI. How we can develop a good AI, how we can develop a fair AI, how can we develop a better AI for better people. Because sometimes people can use it for not responsible tasks. And a computer generated text starts to become indistinguishable from the authentic. The authentic means something that the human generate. And it consider ethical impact of fraudulent. Fraudulent means there will be some issue with the intellectual property. You already write something, but the computer generate the same thing. So it's like job or plagiarism. If used maliciously, it can easily contribute toward the problem of fake news. So that's why now it is one big issue. When you create a text and when you create a fake news, people still do not know whether it is fake or real. And some of the variants, okay, as you know, we learn two things today. The first, we learn about the bird. Bird is using only the encoder. GPT, we use only the decoder. But what if we want to combine the encoder and the decoder? Is there any pre-trained model that use those two? Actually, yes, there is. But using the bird, as you know, the cost is already like 1 million US dollar. And also using the GPT is also the same. The cost is very high. And this one is only encoder, and this one is only decoder. What about if we try to combine encoder and decoder? Because the computation time will be double, or the cost will be double. So the encoder only model, it is good on analyzing text, but do not generate text. So the encoder only model like BERT, yeah, that's good for text analysis. So you can do sentiment analysis, you can do text classification, you can do question and answer pairing, and etc. with the BERT. And if you want to generate text with prompt, so you can use the decoder only models. The decoder only models, for example, the GPT series, GPT-2, GPT-3, GPT-4, and there are some other models like turbo models, Mistral, Llama, Falcon, Vicuna, and so on. So now people try to develop more models. But what about the models in between? If they use encoder and decoder, it is good at analyzing text, but somehow good at generating text. So it is not good at both. So you can use the T5 alpha code, switch, retro, and so on for this encoder decoder models. So this is the development. So let me review a little bit about what they already did. The GPT, it was developed in 2018, and now we have the GPT-4 in 2024. And then the GPT is based on the decoder only. But in this year, so you can see there are a lot of new pretrained model, and they try to fine tune. Fine tune means they have the GPT and they fine tune to a new purpose, and they call it GPT Neo. They use GPT and they fine tune it to a new purpose, they call it GPT J. They have GPT and they use a fine tune and they make a new pre-train, they call it GPT Neo X, and so on. So nowadays there are so many extensions of GPT and there are many extensions of BERT, and yeah, actually we can just reuse it if we want to do some tasks. Okay, then we will go to the code. Maybe I need some time to discuss this code, then I will stop the class today. Let's discuss the code on Tuesday. Yeah.